I'm just going to begin with the introduction that we give about the land trust and the work that we do. I'll provide a land acknowledgement and introduce our guest, and then I will hand it over to him. So I'll just share my screen here for a second. All right, so thank you for joining us here today. I'm Maxwell from the Oak Ridges Marine Land Trust. I'd like to begin this evening with a land acknowledgement. Um, We acknowledge that Indigenous peoples have and continue to have presence and deep connection with the lands on and near the Oak Ridges Moraine, part of what is known to Indigenous peoples of North America as Turtle Island. These lands are the meeting place of two treaties, the land of the Mississaugas of the Credit and those of the Chippewas of Georgina Island, Rama, Beausoleil, and of the Mississaugas of Alderville, Curve Lake, Hiawatha, and Scugog Island, the First Nations of the Williams Treaties. We would like to thank them and other Indigenous peoples for sharing this land with us. We acknowledge that Indigenous peoples have been subjected to colonial oppression and injustice, which continues to this day. We acknowledge that the first step to reconciliation is recognizing Indigenous people and their inherent rights to the land. We will continue to create a better future for our relationship with Indigenous peoples and the land. The Oak Ridges Marine Land Trust endeavors to honor the land and its treaties by ensuring healthy ecosystems that thrive forever. And we recognize that working together with Indigenous peoples to include ecological traditional knowledge systems moves us towards an equitable and sustainable future. So I'll talk a little bit about the work that the Land Trust does. So the Oak Ridges Moraine is a glacial landform that formed about 10,000 to 12,000 years ago. That covers much of southern Ontario. Um, About 90% of the moraine is privately owned, so we work with landowners to help protect valuable habitats along the moraine and help prevent unsustainable development and do things like protect habitat for species at risk, like this Blandings turtle here. We help protect groundwater. The Oak Ridges Moraine is sometimes nicknamed the rain barrel of southern Ontario. It provides a lot of drinking water for people, groundwater reservoirs. So the work we do is all centered around that. Land trusts are a type of environmental NGO, a charitable organization, and we either acquire land outright or interests in land. A lot of what we have are called easements. So somebody might still live on a property, they might even farm part of it, but part of that property is set aside under law to be protected as an environmentally significant habitat. So we protect all of our properties, all of our conservation reserves, which we own outright, and all of our easements in perpetuity. So we aren't able to change our mind in 10 years and decide to put up condos or decide we want to sell things off. All of our 68 protected properties are protected forever. How do we protect the marine? Well, we contribute to the federal government's goal of protecting 30% of land by 2030. We connect people with nature. We do a lot of public engagement and education, outreach activities like the webinar we're doing this evening. We support climate change resiliency. Um, I know I was out in the woods today and I saw Virginia strawberry starting to leaf out, which is a spring wildflower, which you're not really supposed to see in late November. So lots of reminders, especially this fall, about the impacts that we're experiencing with climate change in southern Ontario. And one of the main avenues that we use to help protect lands is the Federal Ecological Gifts Program, which is through Revenue Canada, and it provides landowners with amazing tax breaks and incentives if they want to donate their land or provide conservation easements to organizations like ours. And legacy giving is also a major component of the work that we do. Right now, we're in the middle of a really exciting restoration project out in Northumberland County, out by Ganaraska Forest. We're restoring a site out there. Now, two sites. We just acquired a second property just a few months ago to help support a lost oak pine ecosystem and the species that depend on it. That includes things like the species at risk, like the common nighthawk, the eastern hognose snake, the monarch, short-eared owl, as well as the Kirtland's warbler, which is a extremely endangered songbird, which is very sensitive to where it nests, and we're trying to create habitat for it. And so there's lots of great opportunities to help us out with that and to get involved and to do things like collect seeds from native plants. I'm going to throw a link in the chat for anyone who's interested in learning about any of our upcoming events or volunteer activities that we offer. And we have a lot of great events coming up over the next little while. Next Tuesday, I'm going to be leading a webinar on the lost species of the Oak Ridges Moraine. So things like the passenger pigeon that have gone extinct that used to be found in this region, as well as species that have been extirpated, and what people are doing to help bring back some of these species that have been lost. If you're interested in volunteering with us, on January 14th, we have a volunteer training session over Zoom. We have the return of our annual Owl Prowl at the Beaton Heritage Forest on January 17th. That's a popular annual event. We only have about 25 or 30 spots, so go ahead and register for that if you want to be a part of that. We have a lot of exciting webinars coming up. There's one on groundwater in the Oak Ridges Moraine that we have coming up in February, one on the reintroduction of the mottled dusky wing, which is an endangered butterfly, which depends on that same habitat as the Kirtland's warbler. That's coming up all the way in March. And I'm in talks right now to have a webinar about native orchids in Ontario. So we have a lot of exciting things coming up over the next little while. And I'll put the link in the chat in just a second here for anyone interested in learning more about these events or registering for them. So our guest here today is Mark, and Mark has been in the environmental field since the year 2000. He was the environmental project coordinator with Rouge Valley Conservation House until 2008. He's a certified arborist working in the private industry until around 2016. Um, Became the town of White Church Stouffville's urban forester, dealing with all matters related to trees within the town. In 2022, Mark went back to school. Or went back into the private arboriculture industry. He's a certified tree risk assessor, qualified technician for tree appraisal and consulting arborist. In 2013, he went back to school and took a course in microbiology and compost development and the Soil Food Web School with Dr. Elaine Ingram. And today he's now a certified lab technician specializing in soil biology, qualified compost technician in biologically complete compost, compost extracts, and compost teas. And Mark now runs his own business, Dirt to Soil, which provides an alternative to chemical fertilizers by offering biologically complete compost tea and extracts for cover crops and soil development for trees, plants, and agriculture. And he also teaches arboriculture at Humber College. So I'm very excited to hand things over to Mark this evening, and let's take it away.
All right, thanks, Maxwell. I'm just going to share my screen, and everybody's good with that. Oops, hang on. There we go. Okay. All good then, Max?
Yeah, everything's
Terrific.
good.
Oh, good evening, everyone. As Maxwell was saying, my name is Mark Carroll, and I'm here tonight both as a passionate advocate for the environment and a professional dedicated to the science of soil and plant health. As Maxwell was saying, I'm an ISA certified arborist trained in tree risk assessment, a tree appraisal and consultation, as well as a certified laboratory technician specializing in soil biology and a qualified compost specialist. So my journey into the environmental field began back in 1999 when I coordinated the programs at the Rouge Valley Conservation House. I had the privilege of working with nonprofit organizations like the Rouge Valley Foundation and Save the Rouge Valley System. It was during that time that I developed a deep commitment to conserving the ecosystems. In 2008, I transitioned into commercial arboriculture, and in 2016, I was serving as the lead arborist and urban forester for the town of Stouffville. My role involved tree preservation, care and maintenance, tree planting, and providing insights on natural heritage within the urban planning. Over the years, I came to a realization focusing on trees alone isn't enough. Healthy, resilient trees need healthy soils to thrive. That understanding led me to pursue education in soil biology, where I learned how to enhance soils naturally without synthetic chemicals or commercial shortcuts. Today, I apply that knowledge by using biologically complete compost extracts, teas, and compost itself, and holistic soil management practices to support thriving ecosystems from the ground up. I'm honored to be here with you tonight to talk about what I call the forgotten habitat, the soils beneath your feet. I hope to inspire you to explore this unseen world and understand how it holds the key to preserving the natural beauty and resilience of our environment for generations to come. Before we dive in, I'd like to take a moment to acknowledge the agricultural industry. I realize that when I talk about soil disturbance and tillage, it might sound like I'm being critical. Uh, but let me be clear, farming feeds the world, and the world farmers do as uh, what farmers do is absolutely vital. My goal isn't to criticize, but to highlight ways we can work together to support healthier soils. In fact, this is more of a love letter to agriculture because healthier soils mean healthier crops and better yields and a brighter future for everyone. So, farmers, bear with me. I am on your side if there's some in the audience. uh, so, I'm passionate about the soil because it's a hidden habitat that quietly supports life, yet goes unrecognized and underappreciated. When I look at soil, I see more than dirt. I see a vibrant, complex ecosystem of organisms working in harmony, providing nutrients, retaining water, and building resistance against disease. This hidden world forms the foundation of our environment, supporting the growth of trees and plants and connecting the larger cycles like water and here's a picture of my young grandkids, my inspiration for everything I do. When I look at them, I see a future and I ask myself, what kind of world will we live for them? Healthy soils are at the heart of a healthy environment. They lead to nutritious foods, clean air, clean water. Everything we depend on for life starts with the ground beneath our feet. But here's the hard truth. If we don't start caring for our soils now, when will we? And when will we finally start? Will it be enough to reverse the damage? For me, it's not just about today, it's about ensuring that my children's children inherit a world where they can thrive, a world where the food they eat is rich in nutrients, the air they breathe is clean, and the water they drink is pure. That's why I'm passionate about soils. It's about leaving something better for the next generation, a legacy of health, resilience, and connected connection to the land. So let's start with something familiar, a typical food chain or a food web. Most of us recognize this, plants at the base, followed by herbivores, predators, and on up. Um, it's what we see above ground, the interactions between plants and animals that sustain ecosystems. Most of the time, we focus on what's above the ground, the wildlife we see every day, the towering trees, the graceful deer, songbirds, pollinators like bees and butterflies, even like the predators like foxes and hawks that keep ecosystems in balance. These are species we know and love, and the ones that define the landscapes we treasure. Preserving these species is critical. They're not just the beautiful or iconic, they're vital to the ecosystem's function. Pollinators support our food systems, birds help control pests, predators maintain balance in animal populations. However, their survival depends on healthy, interconnected systems, and that includes the soils. We only focus on what's visible, what we admire 99% of the time. We risk missing the foundation that supports it all. Protecting above ground ecosystems means also safeguarding the hidden habitats below ground. Together, these systems create the balance and resilience that keep nature thriving. But there's a critical piece missing here, and it's what happens below ground. The soil food web, often overlooked, is the foundation that supports everything above ground. Without the life in the soil, microbes, fungi, nematodes, earthworms, and other organisms, plants wouldn't have the nutrients or resilience they need to thrive. The soil wood food web breaks down organic matter, cycles nutrients, builds soil structure, and creates symbiotic relationship with plant roots. These processes feed the plants that form the base of the above ground food web, connecting life below ground to every ecosystem on Earth. If we ignore or degrade the soil food web, the entire system above weakens. Healthy soils means healthier plants, which in turn support stronger wildlife population, clean water, and even better climate resilience. Let's take a closer look at how these underground connections make life above ground. So we'll notice how these two systems are deeply interconnected. The above ground food web relies on below ground uh, relies on the below ground one to function. Plants which form the base of the above ground system, as you can see here, it's when you let me see the so we get and it always starts with the plants and it moves on up. Um, but when you look at the soil food web, it starts at the plants and moves downward and then upwards again into the above ground ecosystem. By integrating these images, we can see that what happens in the soil directly impacts everything above. From the health of plants to the survival of the entire ecosystem, this connection reminds us that managing and preserving soil health isn't just about what's on what's above ground, it's what's underground, and it's about sustaining all life on Earth. Hang on. Uh, Trees and plants are unique in the ecosystem as they are the primary producers of energy through photosynthesis. Using sunlight, water, carbon dioxide, they create glucose, a form of chemical energy that serves as the foundation of the food chain. All other species, animals, fungi, and even some microorganisms are consumers that depend on this energy, either directly by eating plants or indirectly by consuming other organisms. Without producers, these trees converting sunlight into energy, life as we know it would not be possible, as we would be no source of sustenance for consumers. Uh, this highlights the critical role of plants in sustaining ecosystems and supporting all life above. It also highlights the need for healthy soil ecosystems which support trees and plants. It is this glucose that the plants use to build and support life as we know it. It's been doing this for 400 million. As we look at what's going on, the sun provides the energy, and the plants pull carbon dioxide and water out of the air. They produce chlorophyll, which produces glucose, and also gives us oxygen. So without the without the trees and the plants doing this for us, we wouldn't be here. And so this is where it comes into having healthy soils to help support what our plants are doing on for us on Earth. So healthy soil ecosystems can play a vital role in combating climate change. Well-managed, biologically rich soil act as carbon sinks, capturing and storing carbon from the atmosphere. Sustainable practices like composting, cover cropping, reducing soil disturbance help enhance this process, offsetting emissions and stabilizing the climate. One critical step is minimizing soil disturbances such as tillage and avoiding soil compaction. So, as shown in the slides, you can see this is 2006, and it goes from May, and then it hits into July, and then it goes into October. Uh, as shown in the slide, the carbon dioxide emissions spike in April and May, just when you think that the plants are kind of coming out of dormancy and the leaves are um, starting to come out on the trees, you would think that the carbon dioxide would be lessened in the spring and then through the summer. Uh, but that's not what's happening in the northern hemisphere, where most of the landmass is. In the spring is when all the tillage is done through the farm fields. So they have this massive release of carbon dioxide that comes from the farm fields, and this is when you get this massive increase of carbon dioxide and heating in our atmosphere. And then when you come into July through the summer months, yes, it's hot. It's still hot but all the farm fields start to uh, the plants start to come alive. They're starting to green up. They're pulling in the carbon dioxide, so you get that drawdown of carbon dioxide in the air. And then in October, at the end of the season, that's when the trees come off, the leaves come off the trees, and you get that spike again of the of carbon dioxide. And you also get a lot of tillage going on during the fall months as well. So again, the carbon dioxide starts to rise again come early winter and late fall. So studies suggest that tillage can lead to a loss of 20 to 50% of soil organic carbon over time. It also reduces soil moisture through evaporation and increased surface temperatures, which amplifies climate warming. These changes further disrupt the climate system, continuing to contribute to extreme weather patterns like storms and heat waves. So by adopting regenerative practices such as no-till farming and cover crop, we can protect soil moisture, reduce carbon emissions, and we can prevent that massive influx of carbon dioxide in our atmosphere every spring. So while agriculture often takes the spotlight in discussions about soil health, what we do at home plays a significant role too. Care, including soil tilling, over fertilizing, and the use of synthetic pesticides and herbicide, can disturb soil ecosystems and harm beneficial microbes. Even some homegrown solutions like vinegar-based weed killers can negatively impact soil biology if overused. Store shelves are lined with products promising lush lawns, weed-free gardens, but many of these come at a cost of thriving soil food web. Instead of adopting practices like mulching, using compost and enriched soils, and tolerating a little bit of biodiversity in your yard can protect and even enhance the living soil beneath your feet. Small changes at home add up to a big difference in soil health. So, uh, we've all seen these flashy products at the garden center: fertilizers, quick fix lawn enhancers, manufactured mulches, ground mats that promise fast results. Nurseries, hardware stores, and even your local big box stores have dedicated aisles for you to choose from. Turf builders, all-purpose plant foods, fertilizers, spikes, slow-release fertilizers, weed and feeds, lawn boosters, rubber, colored mulches, potting soils, weed barriers, and even rubber mats. Everything to entice you to buy. In my opinion, they're a waste of money, and you can actually do more harm than good. Many of these products are designed for quick fixes rather than fostering a long-term soil health. So if we take time to nurture our environment with natural, biologically complete solutions, we can create healthier lawns and gardens and even forested areas. Proper planting for diversity, and increasing your soil's natural biology will help restore degraded areas and improve overall health of your plants, gardens, and lawns. As we move into the fall, using natural wood chips. Sorry if I keep looking over to my right, I have another screen with the slide on my right. So I apologize for that, but I glance over here just to see what's on the screen here myself. So, uh, but as you can see, these are my gardens. I keep a natural wood chip mulch all the time on my soils. I never get weeds. It took me, it probably took me about 2 years to kind of get the mulch in, have the mulch compost into the gardens, and then as I add more every year, that I don't get weeds anymore because the biology of the gardens around my house have just developed so that weeds don't survive in there because weeds need a certain degradation of your soils to actually grow. So when your soils are really good, you don't get the weeds because there's too much biology in the soils to allow the weeds to grow. So, by just simply putting in some wood chips around your gardens, keeping maybe 5 to 10 centimeters of wood chips on the garden, it does a world of good for your garden and your garden and your plants. And so when you're using mulches like this, try you can actually get them for free. A lot of your local tree care companies will actually dump them on your driveway for you. So and you can ask for a kind of a deciduous base of wood chips. So because they actually break down better than a conifer base wood chip. The conifer base wood chip will have a lot of antimicrobial compounds in it, like pines and spruce. They have the saps that will stop the wood chips from breaking down. So again, when you're looking for wood chips, try and use like a tree mulch, a deciduous tree mulch base for your wood chips. So plants require 17 essential minerals and nutrients to grow, each playing a critical role in their health, resilience, and productivity. Healthy soil biology ensures these nutrients are consistently available by cycling organic matter through a web of microorganisms like bacteria, fungi, and protozoa. This process makes nutrients readily accessible to plants, promoting long-term fertility and balance in the soil ecosystem. In contrast, synthetic fertilizers may offer an immediate nutrient boost, but they often bypass the soil food web. Over time, this can lead to soil degradation, reduced biological activity, and nutrient imbalances. Without active soil life, the natural supply of nutrients slowly and uh, and evenly over time that will stop with synthetic fertilizers. Make and this will actually make the plant more increasingly dependent on those synthetic inputs. By fostering robust soil biology, we create a self-sustaining system where plants can thrive naturally with nutrients delivered continuously in harmony with their needs. So the trees will actually work with the biology. And if they happen to need, say, boron right now, they'll put out exudates and they will tell the biology, the protozoas, the bacteria, the fungi that this is what they need. So if the bacteria, the fungi, and the, excuse me, and the protozoa want to eat, which the plants are exuding exudates, which is the carbon and the sugars, so that if if they want something, they will push out a certain kind of flavor, and the biology will bring those needs to the trees. So when we add synthetics, we provide the minerals and nutrients on our schedule. This weakens the plant's soil biology relationship, and the plants do not get everything they need for survival. So this is a kind of a reduced amount of nutrients that the plants will get if you're putting synthetics on here. And then the plants will actually rely on the pH of the soils uh, for breaking down the organic material and feeding the tree. So it's it's kind of a what I would call a bit of a crapshoot to say, okay, I'm looking for this, but it may not be there. And if the biology is not there because you've added synthetic fertilizers, it's it's basically what's around the root is what the tree's going to get. But if the biology is there, the biology goes out into the soils and it actually brings in all the nutrients that it needs. So the plants aren't just looking to for the pH of the soils to kind of break things up for them. So yes, a good soil pH will provide nutrients to plants, but who has good pH when there's no biology to get you there? Soil pH is a critical factor in determining how nutrients are made available to trees. So uh, this just kind of gives you a bit of a rundown on what pH and the acidity. So acidity is acidic soils are kind of on the lower level from 7 downward, and then the alkaline conditions are from 7 up in your soils. So uh, that's it says the micronutrients like iron, manganese, zinc, copper, and boron are generally more available in slightly acidic soils. So 5.5 to 6.5. This is the type of pH that most conifers like. Um, and in alkaline soils, these nutrients can become locked up and unavailable to the trees, potentially leading to deficiencies. So, uh, when you're looking at your plants, and a farmer will know what kind of soils will grow and what kind of plant will grow in those soils. Uh, but when you have a biology working for you with the plants to make the pH in the soils better for the plant, and then you get that relationship where you get the 17 essential micronutrients available to plants. So we spend a lot of money to get nitrogen, phosphorus, and potassium. That's the NPKs that you usually find in the stores, and that advertises the beneficial uses of synthetic fertilizers. And once you start using it, um, once, sorry, I just have sorry about that. So yeah, once you start using your synthetics, you almost have to continue using it until you make the change and say, look, I want to get off the synthetic inputs and I wanted to go to biological solutions. So you really have to make that decision um, up front, and then it's going to take you some time to kind of heal the land. So uh, we have enough nutrients in the air and in the soil. You just have to let nature provide it to you. So, as the slide says, over every hectare of land, there's 80,000 tons. There's over 80,000 tons of nitrogen. Yet people will go out and they'll buy the NPKs. But if you had the right biology, the biology will take the nitrogen out of the air and it will make it available to the plants. So, um, kind of I sometimes I scratch my head and think, why have we not been doing this all along? But it was, in the early 1900s, they came up with a way to make synthetic nitrogen through what they call the Haber-Bosch process. The Haber-Bosch process synthesizes ammonia NH2, sorry, NH3 from nitrogen NH2 in the atmosphere and hydrogen. And it's derived from natural gas. So under high pressure and temperatures and using a metal catalyst, this is all science, and this is where going into science, soil biology, you could really go down a rabbit hole. But I'm just kind of going to go down this little rabbit hole real quick. So developed in the 20th century, this method revolutionized agriculture uh, by producing nitrogen fertilizers on an industrial scale. These fertilizers have greatly increased global food production, supporting billions of people. However, overuse has led to environmental challenges such as water pollution, greenhouse gas emissions, even to the production of the synthetic fertilizers adds huge amounts of greenhouse gases to our atmosphere. And then you get into soil degradation from the use of it. So the process highlights the duality of innovation, solving a critical problem while preserving a new challenge for sustainable management. So in the early 20th century, farmers started tilling, and the biology started to kind of be reduced in the soils, but they owned the land and now they couldn't grow crops. So that's when somebody came up with the use of synthetic fertilizers. So, but if they stopped tilling and were using cover crops back in the turn of the 19th century, then we wouldn't need the synthetic fertilizers today. So, and again, so when you're using synthetic fertilizers, you pay for 100% of the product. but you only use 40 to 50% of it. So what if I told you that we will make you pay 100% of your electricity bill, but you can only use 50% of the electricity? I think you would have a different outcome on what you're going to be paying for and what you're going to be using. So, um, but again, it's one of those things where, like I said, I don't want to criticize the farming community. These things just need to be kind of highlighted and brought to the forefront, and maybe we can change some minds to go into no-till farming. So this slide is one example of the soil-plant relationship, one of the most important relationships. This slide shows the nodules on a legume that are filled with what they call rhizobia bacteria that turns atmospheric nitrogen into ammonia for that is available to plants. So uh, the little nodules on the roots of the plants, they're filled with the rhizobia bacteria. It's not the plant that is kind of taking the nitrogen out of the air, it's the rhizobia bacteria. And the above picture there is the actual nodules that can take nitrogen and turn it into available ammonia for the plants. So you get this on legumes. Clover is a great one. Any of the white or red clovers, they are a plant that will attract the rhizobia bacteria, and um, they can feed the nitrogen to the plants that are around them. So uh, my my grass I have overseeded with clover. So I have my grass and I also have clover mixed in with it. So, but doing so that does two things. It feeds my grass with nitrogen, but because the clover is a bit of a broadleaf plant, it also holds the water, the moisture from a rain. So even 2 or 3 days after a rainfall, my lawn is still wet and green and lush, where most other lawns in the neighborhood are starting to brown off. So uh, so the legumes. Your peas, your soyas, your soybeans, your clovers, your black locust and honey locust. They're great trees to have on your front lawn because uh, they are also attract that rhizobia bacteria that can turn atmospheric nitrogen into available nitrogen for the plants. So other relationships with the soil organisms to access nutrients, mycorrhizal fungi. I think everybody's starting to hear about what mycorrhizal fungi can do. Our own Canadian forester scientist, she's got a bunch of things in her name, but Suzanne Simard, she discovered that relationship back in the 80s, where she discovered that birch trees were actually helping. Um, uh, what was the tree? It's a conifer in the forest, and so during the spring, the Douglas fir would help the birch trees to survive, and the Douglas firs would give exudates into the soils, where the mycorrhizae fungi would pass the nutrients to the birch trees because there's no leaves on them. But once the leaves came out on the birch tree, the the exudates went the other way. So then the birch tree started to help the Douglas firs in getting nutrients and stuff. So that the mycorrhizae fungi the discovery was a huge asset to the forestry industry. And as they do monoculture plantings, it's almost wise to throw in some of these other hardwoods so that you get that relationship going on, not only with each tree, but with the soils as well. So in addition to the rhizobia bacteria, there are other bacteria that will provide nitrogen. They don't have to attach to the roots. Uh, so there's decomposer microbes that so fungi and bacteria break down organic material into simpler compounds, and that's excuse me, that's for nutrients like nitrogen, phosphorus, potassium, and all the other 17. macro and micronutrients come from is just that breaking down of the organic material. So again, there's lots in the soil, there's lots of different associations happening. And remember, plants don't walk around. They can't go to the store and pick up, your milk and eggs and whatever. They're in the ground. They don't move. So whatever's in the ground for them, that's all they get. So they have to make that relationship with all the microbes in the soils to get the right nutrients that they need. Excuse me. Yeah, sorry about that. So the the rhizophagy cycle is a fascinating plant process where plants farm certain microorganisms. So as you can see, you've got this is a picture of a root that kind of looks like a pencil, but uh, the root tip at the very on my right over on this side of the picture um, is the root tip. So it's sending out exudates to bring in the bacteria. So whatever they're sending out the bacteria likes, they'll come to the plant where now the plant will pull in the bacteria into the root. And as it goes along the root, you can see the little here, let me get my you can see the little kind of area will now be pushed along, and the plant will actually use enzymes to strip the shells off the bacteria, and they will pull out the nutrients that the bacteria has in them, and then through the root hairs it will spit the what's left of the bacteria back out into the soils, where now the bacteria will now kind of fix itself, and then they go back for more. So it's kind of a circular relationship that's happening in the soil. So these root hairs, they're important to the the root to push out that bacteria, and then it just goes back around and it just does this circular motion with the bacteria that's in the soil. So and one of the things when you add synthetic phosphorus, you stop that relationship. Because the plants, they don't need to push out the exudates to the bacteria. They just pull in whatever they can reach for the phosphorus, and they don't. When they're not pushing out exudates, the bacteria either dies or just goes away. Bacteria want to find an area where they can get the nutrients for themselves to survive. So if there's nothing around the roots, then they're not there. So when this phosphorus is gone from around the roots, there's no bacteria there to feed the tree. So now you're not getting anything in the roots. The trees basically has this, it's alone in the soils, and it doesn't have the energy to push the roots out to grow the roots as fast as it would if it had the biology in the soil. So uh, when you're using synthetic NPKs, you really doing your plant a world of good here. So, uh, this slide showing a small tree surrounded by a network beautifully illustrates the powerful partnership between trees and mycorrhizal fungi. The fungi connects to the tree roots, creating an underground web that extends far beyond what the tree could reach on its own. This network enhances trees' ability to absorb nutrients like phosphorus and nitrogen, as well as water from the soil and all the other 17 essential nutrients. In return, the tree provides the fungi with sugars produced through the photosynthesis of the that is produced in a tree through photosynthesis actually goes out into the soils uh, to make that connection with all the microorganisms in the soil. So this relationship not only benefits the tree, but it also links it to other plants in the area, forming what scientists call the wood wide web. Through this network, trees can share nutrients, send chemical signals that threats like pests and even support neighboring plants. Like so, this again was what Dr. Susan Simard came up with using a scientific way of tracing elements back and forth through the roots and through the mycorrhizal fungi. So you can see here. Hope everybody can see that this is a little pine tree, and the roots come down, come down, come down, and they stop about here. So your root system of the tree is just in this little area right here, but the mycorrhizal fungi network is huge for this one little tree. So the first 5 years of a tree's life in a seedling form, they're pushing out as much exudates as they can because they want to develop that relationship with the soil. So whatever photosynthesis that is happening within this little top of the tree, most of the sugars that are created are pushed out into the soil so that it can create this relationship with the soil. Uh, so this picture here shows the mycorrhizal fungi connected to the roots. So there are two different types of mycorrhizal fungi. There's ones that connect to the roots, they go into the roots, and then there's ones that will surround the roots. And kind of with the exudates coming out of the root from the tree, then it will take the sugars and the exudates, but it will bring in what the tree needs as well. So again, not all the mycorrhizal fungi actually get right into the root of the tree. There are some that's kind of just surround it. So what this is also doing is protecting the tree from other pests and diseases. So you can imagine if some other root came into here that was like a pest of some type of uh, uh, fungus or something that wasn't good for the tree, it couldn't make its way through all this. And even if there was bacteria, there was kind of a bad bacteria that came in here, it wouldn't get through this because there's bacteria as well in all this fungal root system. So fungal hyphae can also break down organic material and sediments in the soils to mine for nutrient minerals that plants need. So enzymes from the microorganisms form humic acids, fulvic acids, and ulmic acids, which break down even sand and rock in the soils. So it'll break down organic material and it will pull out the nutrients out of that sand and rock and organic material. So a healthy soil is far more than just dirt. It's a living, breathing ecosystem teeming with life. But microbes like bacteria and fungi to nematodes, protozoa, and earthworms, this hidden habitat supports an incredible web of life. So these pictures here, if I could get this, this is mycorrhizal fungi right here. So if you, this is done under my microscope. So if you could think, I have a little 18 by 18 millimeter uh, uh, slide. I put it under the microscope. Now, in that 18 by 18 millimeter slide, there are what we call 2,000, over 2,000 fields of view. So that's the little point that you actually look at through the microscope. So this is one field of view. So this is just that one of those 2,000s of one of those 2,000 fields of view. So you get testate amoebas. You get all these little testate amoebas in here. This is a little bit of this is a flagellate here. This is mycorrhizal fungi. This right here is a rotifer, and this is a nematode. So these are some of the organisms that are in there in the soils that are helping to drive that soil food web. So when we view soil as a ecosystem, we recognize its vital role in sustaining plant ecosystems and the health of our planet. Without this biodiversity, soil becomes lifeless dirt. Maintaining and restoring soil life is key to fostering resilient ecosystems and a sustainable future. So this is just showing two different types of soils. This one, the one on the goods, underneath good, is soils that have gone through the regenerative process. So it always had some roots there to feed the soil biology. And the not so good soil is what's been tilled. So you can see on the good side that the roots go down deeper. They can go into 5, 6 feet down into the soil. So when those roots go down there, you can imagine how much water and air is being held in the soils. So um, we need to get those that soil biology back into the soils so that it compact it takes the compaction out of the soil and allows the roots to penetrate lower and lower and allows the water and air to get down deeper into the soils. And then we start holding more water in our soils. And we also have more organic material in our soils. It just brings in more and more what plants need to grow with. Oop. So this is in Colorado in 2022. They kind of had some problems down in Colorado. So I managed to get some pictures from somebody that does the same thing as I do in regenerative agriculture. So the uh, on my left, I'm not too sure what's on this side of the picture where it's nice and green. This guy does no-till crop rotations. He does the regenerative agriculture and never has anything. He never has bare soils. The one where you see all the water, get my where you see all the water over here, he does just the traditional tillage and cover and crop rotations. There's no grazing. So on here, there's actually grazing of livestock. So, but he does manage grazing. He doesn't just let the cows go out and eat wherever they want to. He sections off his farm so that the cows will stay on a set part of that field for maybe a day or two, and then he pushes them to another area, and then he pushes them to another area, and that way the cows kind of eat the tops of the grasses. He doesn't the cows don't destroy the grass, eats the tops, moves on, and then the actions of the cows pooping everywhere and just eating the tops of the grasses will grow much faster. The soils will become better, and the roots of the trees will actually go in deeper and hold a lot more rain. So again, this is Colorado. In 2022, they had their problems. So in June, or sorry, in May of 2022, they had such a dust bowl down in Colorado when they came out of the winter months that the soils were so dry. There was no crops on the soils, so they had these massive dust storms. Come June 2022, with the rains, the ground was so hard that it did not absorb any of the rain, and they had floods. So there's only a month in the difference of that, and they really had some major problems down in Colorado. And that's again, you can see you can see up in the corner here that the regenerative agriculture was happening on this. They had some soils there. They had some crops on the soil, and the soils were able to withstand a lot more rainwater. But again, majority of soils, 90% of the croplands anywhere in the world are tilled, and these are the problems that you're going to get. So So my work with biologically complete compost extracts, and teas focus on restoring soil health by reintroducing essential microorganisms that drive nutrient cycle, improve soil structure, and support plant resilience. So I also collaborate with the farming community to promote regenerative practices like cover cropping and no-till farming. So cover crops such as clover, oats, radish, and rye. There's many more. You really have to look at the soils that they have. They help stabilize the soil, prevent erosion, and enrich it with organic materials. So the cover crops are there so that uh, the rye and oats will have deep roots. They'll go way down into the soils. And the clover, again, the clover will bring in the nitrogen, and the radishes have that huge. They'll develop a huge taproot, but the radishes don't survive over winter, so that taproot dies and leaves that huge hole in the ground for water and air to get in, so that the microorganisms ground can survive with that water and air. Without doing that, so a lot of farmers will say, "Well, I'm not going to till. I'm just going to kind of leave the cover of the last year's crop on there." Well, last year's or the last season's crop will die, but it's not actually getting deep down into the soils, and it's not putting like the clover's not going to give you the nitrogen. You're going to get a bit of a cover crop on there, like a mulch, but it's not really going to repair the soil. So you need to get the cover crops on there so that you have living roots in the soil all year round, and then that will keep your microorganisms alive all year round. You have to remember in the winter you get almost you get more biology working at on the mulches and breaking down the organic materials, because once you get that cover of snow, it kind of insulates the soils, and that's when the bacteria really starts to break down the organic materials, so that when you plant in the spring, everything's there. But again, you still need that live root system in the ground to keep all the microbes alive through the winter. So again, change, however, can be challenging. I've started doing a place up in just kind of up north of Barrie, and it really took me about 3 months of persuasion eh, to get a guy who wanted to start a tree farm to go into kind of a regenerative method of growing the tree. It was a good lesson for myself. He asked every question. He talked to people. Some people he talked to said I was crazy. Other people were saying, you know what, that's a good idea. Maybe we should try that. So I'm hoping that more and more people kind of get into this regenerative agriculture end of things, and start looking at what their soils to help them grow whatever they want to grow on their land. So again, it's really hard to take somebody who's in the agricultural field and say, you've been doing something for the last whatever many years or decades of your life. We want you to change. And it's not always easy. So, and then we also have to look at what's happening in the GTA. A lot of lands aren't owned by the farmers. They're owned by developers. They're just leased out to the farmers, and a lot of farmers, they don't care what happens in the future. They just want to get that cash crop on the ground, off the fields, and then move on. So they're not really looking at the future of those lands. So we have our work cut out for us in this area. So, but I'd really like to get some really good examples going. There are more and more people doing this in North America, but it's only about somewhere between 5 and 10% of all the agricultural lands are under regenerative agriculture. So, and then there's more and more people even at the home base, the gardens and the lawns, that are looking at this. But again, it's such a minute amount of people that uh, we still have that problem with overuse of synthetic fertilizers. Everybody seems to have one of these, oh, I tried lasagna mulching, I tried this, I do this, I do that, and still the weeds keep coming, and I will, spend a few hours every month trying to pull weeds. But if you got the biology right, a lot of things would take care of it by itself. So we also have an incredible opportunity. Sorry, it's getting to an hour there, so I'm watching the time, Maxwell. So We have I'm almost done. So we have an incredible opportunity to lead by example with federal lands like the Rouge Park agricultural lands. These lands are owned by Canadians and should be farmed regeneratively to demonstrate sustainable agriculture in action. Uh, with Canada's commitment to the Paris Accord, where the regenerative agriculture really took hold within the UN, uh, there's a clear call to adopt practices that build soil health, store carbon, and protect our environment for future generations. So, um, I have talked to our Liberal MP. She looked at me like I was crazy. I've been trying to get hold of the supervisors that run uh, the Rouge Park agricultural lands. They don't want to return my phone calls. So, but the farmers leasing these lands have the potential to set the standard for regenerative agriculture in land. So remember that the federal government put 6,500 acres of land into into natural lands for agriculture and for wildlife habitat. A lot of those lands are being just farmed like they have been for years. But if we could change that, if we wouldn't have to grow trees. We could just grow cover crops. We would always have this clean air, clean soils, water holding capacities right in the agricultural lands. And it's a great opportunity. And I'm not too sure why. I mean, Canada's signed on to this back in 2018, but they haven't looked at the federal lands here right in the GTA to say, you know what, this should be an example. And that's one of that would be a goal of myself. So um, let's see, hang on. Yeah, so there we go. So just some interesting facts. So 2.5 centimeters or 1 inch of rain on 1 acre of land equals 27,000 gallons of water. Um, and raindrops drops at a speed of about 40 kilometers an hour. I think I have that one wrong, but I think it's 25 kilometers an hour. And I was like thinking 25 miles an hour. So I think that should be 25 kilometers an hour. Uh, so when you leave soils bare, that rainwater coming down at that speed will actually compact your soils just from hitting your bare soils. So again, when you're leaving cover crops on there, you're stopping that rainwater from hitting the soils at that speed, and it hits the cover crop, and then it just drains into the soil. So you don't get the compaction of the soils like you would with having bare soils. So um, we have a farm just south of us, just in the south part of Stouffville. uh, the farmer did have a crop of red clover throughout the whole thing. It was looking great. But then he went in and he cut it all down. I went to get a sample of the soil. I couldn't get my shovel in the soil. It was so compacted that, and I sharpened my shovels just for that reason. I literally could not get a sample of the soil because I couldn't get a shovel into the soil. Um, so you can see he started on having a cover crop with the clover, but then he cut it all, and the rains came, compacted everything, and basically the rains just washed off. And that soil, even with the rain that we've had over the last little while, it's still hard as rock. So that I don't know, Max, if I have a couple of things here.
Oh yeah,
Just
please,
to,
please go ahead.
yeah, yeah. Um, just some things I could show you. Come on now, real quick. Where is it? Let me escape out of that. Come on. Uh, so what I was saying before, when I look at things under a microscope, you can all see this, right? I take it. This is what they call a rotifer. Uh, and it's one of those microscopic organisms. And what it's doing, it's actually attached itself. The tail is at the top of the screen. Uh, is up here. There's its tail right here. So what it does is it kind of sticks to organic material, and then it waves itself all around, and it just pulls in bacteria. It eats bacteria, and then it's starting to poop out some of the nutrients and stuff. So you can see here where this is the stomach here, and it's just going around, and sometimes you can actually see a whirlwind of bacteria just being pulled and drawn into the mouth of the rotifer. So again, this is 1/2000th uh, of the microscope. So you can see how small this is. So you don't know they're in there. You don't see this, but that's what's happening in our soils. So I know I have a. Where's the other ones? What else have I got? This is what they call a water bear. It's a tardigrade. It's another little arthropod. I think I have one that's moving around somewhere. Again, these are testate amoebas right here. They pull in uh, bacteria. You can see all the bacteria moving around. Sorry, I keep forgetting. You can see all the anything that's moving, all the little dots. That's the bacteria in the soils, and over here you get the organic materials. The sands and the silts are in here as well. So this is just a, a protozoa that's moving around. You can see some of the tentacles that it uses to kind of pull in some of the bacteria. Come on, where are you? This is a nematode. I caught this one sleeping. So this also is in the soil. I always like this. I always like if I can get in a drop of water, if I can get two or three nematodes, then my compost is really good. So this is a bacteria feeding nematode, and you can tell by the mouth that's here. At least I can tell by the mouth the structure of the mouth. There's an esophagus here. There's a bulb here, and then there's the another bulb here. But again, it's that's a nematode. What else we got? Okay, and this is just another picture of mycorrhizae fungus. We could tell this usually this one's a bit damaged because when you break up the material to do a sample, you could damage some of the microorganisms in there. So um, and we're just looking at what's in the soil, and this is the what we look for in when we're doing a soil sample under the microscope. So we have to actually focus up and back, up and down through the water, the water in the sample. Again, just another picture, all the bacteria that's in there, and another picture of the of fungus. Um, I don't know if you can see that. There's kind of a shadow here. I that's a flagellant. So there's certain microorganisms that are in the soils that we could tell if you've got aerobic soils, you've got good soils. So there's air, there's water in the soils, and you're providing the right habitat for all those soil microorganisms. But if you've got anaerobic, you're going to get a whole whack of different organisms, and those organisms, those are usually your disease carrying organisms. So you don't want anaerobic organisms. So when farmers are out there and they're putting out the manures onto the soils, there's a process that has to go through those soil that manure that has to break down and it has to kind of turn into an aerobic a habitat for the right microorganisms. So what the farming community should do is that they should compost the manure first with the right ingredients and then spread it once they've broken that anaerobic material down to aerobic. the aerobic microbes will take over, and then they should use that to be putting out on their fields. So there's a step there that needs to be done in the agricultural community. So when I make compost, I don't use. I have three dogs. So I do not use their feces in my manure because what comes out of a dog is anaerobic, and uh, if the dog happens to be sick, then it's not the right stuff, and you just really need to get your pile up to about 160 degrees to break that down and get rid of those diseases. So this is the hang on, whoops. I like to get this picture first. Okay, so this is the tree farm that I was doing up north. This is what it looked like at the beginning of the season. They planted the rows of trees. Unfortunately, they planted too close, and it really made it difficult for us to get in there and seed and do the right things for the soil. But uh, that's what it looked at the beginning of the season. Where'd it go? Again, sorry, it's so again a little bit of a close-up picture. The soils are bare. There's really when we took the soil test, there was nothing in the soil. There was no biology in the soil. I'll get to these pictures, and this is what it looked like back in at the end of October. So there we planted a cover crop. So there was oats, there's rye in there. There's some weeds in there, but what we call weeds, they're still plants. They'll die over the winter, and they will provide some mulch on the soil. So all this, there's white and red clover. There was oats. There was we had radish in here. So this really looked good when during the summer the weeds did kind of take over. We did a cut of the weeds or the plants that we didn't want there, and then we overseeded with this, and then what we got was a uh, better cover crop that so all the trees are all mixed in there with it. We've got nitrogen fixing clover in there, and we've got oats and rye that will get their roots to penetrate down. There's radish in there. There's really not a lot of radish. I think it was only like 3% of the seed base that we put down was radish. It's because you just want to start the holes getting in there. So this is my compost in my backyard. So um, this pile right here is an established one. I got that at the beginning of the summer, and this is what I use for compost teas and extracts. This one here should be ready for spring. It's still in the cooking mode, and kind of the I want to break down the organic material and get and start building the microorganisms in this pile. What's what I got? Again, that's the piles. This one, this pile here, I've got holes. I want air to penetrate through the pile, so it's not very tall, and I've got holes in the pile, so that the air will circulate through the pile and will keep that pile anaerobic. So I don't want to have to keep turning it because when you turn the pile, you destroy the mycorrhizal fungi that's in the pile. So every now and then this pile will have mushrooms all over it, which is a great sign because you want to have that fungal presence in the soil. And this one here, it's a little bit taller because you want the heat. You want the heat to build in the middle of the pile, and then you flip it. So it goes through a process of 3 or 4 flips until you kind of kill all the seeds in there that you don't want and all the bad stuff that you want in there. So, and this is something you could do at home uh, with the right ingredients. This is a little orchard that we started on. So he was having all kinds of problems with his trees. So what I've told him, so what he's got now, I don't have a picture of it at the fall here, but they took all the grass away. They put mulch around all the trees. The the people who were looking after his lawn were actually killing his trees. They were hitting it with the string trimmers, and they were kind of girdling the bottom. So they were taking all the bark off the base of the trees. So they put the mulch down around the trees, and that kept the grass cutting guys away from the trees. And then we came in and we put in our extracts on all the trees. So we're hoping the the orchard. Some of these trees are dead right now, just because of the grass cutting guys. So and this is his greenhouse. So we came in there. He's got vegetables, fruits and vegetables. This is down in Ancaster, and so we fertilized all these. He's a vegan himself, and he wanted nutritious foods for his family. And he knows that using synthetic fertilizers, you're not going to get the nutritious values that your food. So once you start using synthetics, because the plants aren't getting all the uh, micronutrients, macronutrients, that relates back to you because now you're not getting all the nutrients that that plant can actually provide if it was under a biological fertilizing. So uh, I would say 60 to 80 years ago, if you took an apple, you could eat one apple and get a lot of nutrients. You would need to eat 8 to 10 apples nowadays to get the same nutrients. Because of what they do with apple orchards, they're spraying pesticides, they're using chemical fertilizers. What's happening now is that they're not producing food, they're manufacturing food. And we're seeing the health effects on people that because of that. So this is just my little backyard composting, but that compost goes a long ways. I use about 40 pounds per third for a 1,000 liter tank, and I bubble that, and I could do about an acre of fertilizing with that 1,000 liter tank. I also have a relationship with restaurants. They have a great abundance of compost. Coffee grinds, tea grinds. I have stacked restaurants here in Lindsay. I bring in all their compost. So anything that comes out of the kitchen, I don't take the stuff that's on the plates because there's preservatives, there's meats, there's all kinds of stuff on the plates of the waste. I take what's in the kitchen where you get all the offcuts. There's no preservatives on that. You get, like you said, you get coffee grinds, you get eggshells, which is great for calcium. You get, your they have potato. They cut their own stuff, so all the waste goes into a bucket, and I pick it up once a month or so. But you can see all the buckets that we get. Um, the last time I picked up 27 buckets of compost, and each one weighed about, I would say somewhere between 5 to 10 pounds. So if we said 5 pounds per bucket, you can imagine 27 times 5, 25 to 100. They're about 150 pounds of compost or waste that's not going into the landfill is now being composted in my backyard. So that second row of compost has 4 drops of those anywhere from 20 to 30 buckets. So I've taken almost 100 buckets and put in of food waste and put it into that one row of compost. So I would urge residents to, if you could get a relationship with a local restaurant, again, take the food waste coming out of the kitchen, put it in a compost, go to your local tree care company, get the get the wood chips that you need. Make sure that their deciduous is the best, but it can be mixed with conifers. And if you've got a high energy, a high nitrogen ingredient, you can get the spent grains from the local breweries. That's great for a high nitrogen to kind of get the pile going. And you can also I use manures from a local duck farm. Great for getting your pile, getting it to cook so that you can kill all those bad weed seeds and stuff. So uh, it's very simply done. I've talked to the um, head office at Stack's Pancake and Breakfast House. They want to do it with all their restaurants. The only thing is it's how to get and deal with the food waste. We need a place to put that food waste and then a process on how to compost it. And I'm not there yet. So it's one of those things that it's a great thing to do, but I'm just not in set up for receiving. I think there's like 40 stacked pancake houses in Ontario. So I don't know what I would do with, I don't know, 500 buckets of compost every month or so. So, but um, but that's it. Yeah, that's me. I'll turn this back to you, Maxwell, and
So
see
nice.
if we have time for questions.
Yeah, it looks like we have a couple questions here. Thank you
Good.
so much for sharing all of that. The footage of those microorganisms, the rotifers and tardigrades, is so cool to see.
Yeah, so you can understand what is underneath your feet. Now, walking on soils, you're not going to kill them,
Mhm.
because I mean yeah, they're like a micron in size. So you get 1,000 microns per millimeter, so you can see how big they are. So um, yeah,
Yeah, it's amazing to think about.
yeah, yeah.
There's one person here was asking if just ordinary yellow and green beans fix nitrogen.
Any of the legumes, so any of the bean family will actually have that possibility of attracting the rhizobia bacteria. So one of the good things for a cover crop. So if you're and what you see on the fields now is they go from corn to soy back to corn. So the corn sucks up so much nitrogen that the following year you can't, if you don't have the biology, you can't grow corn again because there's no nitrogen. So they usually go to the soybean, and the soybean then will put the nitrogen back into the soil. So and that's why you get that back and forth switch. So again, yeah, any of the beans, and like I said, if you look up legumes, that will give you a list of the plants that will actually have that the nitrogen fixing opportunities.
Perfect. And the other question, we had one from Carolyn here who was wondering, we plant 50 tree saplings in poor sandy soil with little organic matter. Does it make sense to amend the soil with bone meal or rich topsoil in the planting hole? She says the new school of horticulture says don't amend the soil in the planting hole. She was wondering what you thought.
Yeah, so I'm going to share this one again. It actually just happens to be up here. Uh, so this field here, we didn't amend the soils. Oh, sorry, hang on. There it is. So this field, we didn't amend the soils. The only thing that we did is we put cover crops down. So if you have sandy soils and you want to get something in there, you can overseed even over the trees. You can overseed with some kind of like a clover. Clover does great on sandy soils. You could do oats and rye to go on there, because the oats and stuff will get down there. They'll hold the soils. Sandy soils can move. They can compact. They're if you don't have anything on them, the water can evaporate really quickly out of sandy soils. So again, you have to get the cover on there. So again, I'd almost say before you plant, do a cover seed, get the organic material in the soils, and then if you did that in the spring, and then you could plant your trees in the fall once you've got that organic mat on the ground. Um, so planting, like I said, the guy who planted these trees got ahead of me. I came in July. He had planted in May. And then I said, look, he was wondering about this field, and I said, look, we could do this, and this, and it took me forever to get him going. So we actually planted a cover crop in August. Thank God we had all that rain that we did through the summer, and the seeds took, and you can see what. Oops, where'd it go? you can see how that happened. So again, we took that field with nothing, and we have what we want to see around those trees.
Perfect. Well, I think
Yeah,
those were the only two questions.
yeah.
Uh, that might be a good point to end for the evening. But thank you again, Mark, for joining us. It was really wonderful to hear you speak, and yeah, fantastic to see the difference that you're able to make at that tree plantation.
So
Uh,
I'm just gonna, if you don't mind,
oh, absolutely.
I'm gonna put up my information. Come on here. It's not working. Anyways, you can see that. So I have a couple of emails, environment first at rogers.com. So I've had that for years. And I've always thought that in the planning process, we need to take the environment first um, and then kind of work forward from that. And then my company, so the dirt to soil is dirt two underscore soil. Sorry, the underline there kind of got in the way of the underscores. Um, and you can catch me on Facebook. I don't have a website. I'm sorry right now. Doing the doing this type of process, it takes a while to kind of build your bank account up because what you're actually doing is you you want to work yourself out of a job because eventually you're going to build those soils up with the right organic material and the right biology, and then you never have to touch it again. As long as you have living roots in the soil, your organic material and your microorganisms will always be there.
Hard
So
to have repeat customers if you do your job well.
yeah, I figure I got about anywhere for three to 5 years. If you get really degraded soils, you have about 3 to 5 years to actually build them back up. By the time you get the cover crops on there and they get the soils kind of back into to healthy structure, and the microorganisms build up. So, I've got 3 to 5 years with a customer, and then they never want to see me again. So it's not like a fertilizing company where they want to see you every year to come and pick up all those bags of fertilizer. And fertilizer's cheaper. My process is a little bit more expensive, but again, you're working me out of a job. So,
It's a fun way to think about it.
yeah,
All right. Well,
yeah,
thank you for joining us this evening, and thank you to everyone who was on this
yeah,
call and watched this presentation. There'll be a recording available, and if anyone wants to connect with
yeah.
Mark, I'm happy to pass along the email that you shared. And yeah, hopefully we'll see you at the next webinar. And everybody have a
Yeah, just if I could, I'd like to thank everybody for being here tonight, myself, and thanks Maxwell for the opportunity from the Oak Ridges Marine Land Trust. So I know the work you guys do are great, is great, and I've watched you from the start. I've been involved in the Oak Ridges Moraine, advocacy end of things for since it started in 2001. So, yeah, it's been nice, and it was a big threat when Ford kind of it kind of gave us a scare there. But I think the residents of Southern Ontario said, you know what, no, 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 you're going to keep our Oak Ridges Moraine and our greenbelt intact.
yeah, hopefully things are safe for the next little while.
Yeah, keeping our fingers crossed, right?
All right. Everybody have a nice evening, and thank you again, Mark. It was really great.
Thanks. I hope I got what people needed across. So
For
yeah,
sure.
yeah. Okay. Thank you.
Thanks.